On July 4, 1961, the Soviet Union's most advanced submarine drifted through the North Atlantic. Inside the hull, 3 maintenance lights began to flash. Each one signaled a critical failure that required immediate intervention to prevent the loss of the vessel. The first warning originated at the bow. The secret communication line to Moscow had gone offline, severing the ship's link to high command. This loss of communication left the crew isolated. Without a way to receive orders or request a rescue, the K-19 was now a rogue vessel in the middle of the ocean. The second light signaled a problem midship, where 3 silos held R-13 ballistic missiles. The silos were overheating, threatening the stability of the nuclear warheads. This chart compares the explosive yield of an R-13 missile to the bomb dropped on Hiroshima. Each Soviet warhead carried 66 times the power, enough to erase a city in seconds. At the back of the submarine, a third light indicated that the nuclear reactor had reached 300 degrees. If the temperature hit 600, the core would melt down. An explosion of this magnitude so close to a NATO base risked being mistaken for a first strike. A mechanical failure in the Atlantic now threatened to trigger the start of World War III. This diagram shows how the submarine generates power. Core atoms split to create heat, turning water into steam that spins the turbines. The crisis was caused by a fracture in this cooling pipe. Because construction was rushed, designers failed to include a backup cooling system. While the crew scrambled for a solution, a United States Navy warship intercepted their distress signal and offered to evacuate the crew. If you're interested in the engineering and hidden history of the Cold War, subscribe to the channel to see more deep dives like this one. Captain Zatev faced a choice: accept American help and risk being charged with treason for surrendering military secrets, or find a way to fix the reactor alone. He ordered his men to stay on the ship. Engineers planned to reroute the ship's drinking water, welding supply lines directly to the reactor's air vent to flood the core. But creating a secure weld was nearly impossible. Constant condensation prevented the metal from bonding, while the engineers struggled to breathe. 8 volunteers entered the reactor chamber in 10-minute shifts. They worked in a high radiation environment, cutting and welding through the steam to save the vessel. The success of the repair relied entirely on the physical endurance of these men as they exposed their bodies to the reactor's core. The final weld held. As the drinking water flooded the system, the temperature gauges began to drop, and the immediate threat of a nuclear explosion ended. This chart shows the radiation dose the engineers absorbed, measured in Roentgens. While 400 Roentgens is typically a fatal dose, the men inside the K-19 were exposed to 5,400. All 8 volunteers died within days as their internal organs failed. Within 2 years, 14 more crew members succumbed to radiation sickness. The Soviet government immediately classified the incident to protect the military's reputation. Medical records were sealed, and survivors were threatened with prison if they spoke about the disaster. The crew of the K-19 remained unacknowledged for decades. Their story only emerged in the 1990s, finally identifying the sailors who sacrificed their lives to prevent a nuclear catastrophe.